Hello, teacher. Okay, the wave function of state with specific values of a physical quantity, linear, and the Hermitian operators. What is a wave function? Wave function in quantum mechanics variable quantity that mathematically describes the wave characteristics of a particle, and the value of the wave function of a particle at a given point of space and time is related to the likelihood of the particles being there all the time. And by analogy, waves such as those of sound, a wave function denoted by Greek letter psi, may be thought of as an expression for the amplitude of the particle wave. Also, for such waves, amplitude has no physical significance. The square of the wave function, the second psi, however, does have physical significance. The probability of finding the particle described by a specific wave function at a given point and time is proportional for the value of psi second. And these properties of wave function. All measurable information about the particle is available, and the first psi should be continuous and a single valued. Using the Schrödinger equation, energy calculations becomes easy, and probability distribution in 3 dimensions is established using the wave function. And the probability of finding a particle, if it exists, is 1. The physical significance of wave function. There is no physical meaning of wave function as it is not quantity which can be observed. Instead, it is complex. It is expressed as psi, and from this formula, and the complex conjugate of the wave function is expressed as psi, and multiplied 2 times, and from this. The product of these two indicates the probability density of finding a particle in space and time. However, psi is a physical interpretation of wave function as it provides the probability information of locating a particle at a location in a given time. And we should know that there must be a single value for psi and it must be continuous. And next, linear and Hermitian operators. An Hermitian operator is a physics version of an object that mathematicians call a self-adjoint operator. It is a linear operator on a vector space V that is equipped with positive definite inner product. In physics, an inner product is usually notated as a Bray and a cat following Dirac. Thus, the inner product of P and psi is written as this, and here V is in the bra and the psi is in the cat. And the Hermitian operators, we should know that the physical variable must have a real expectation values. This implies that the operators representing physical variables have some special properties. And from this image, we can see the formulas, Hermitian operators, and by computing the complex conjugate of the expectation value of a physical variable, we can easily show that physical operators are their own Hermitian conjugate. And the next, a function f is called a linear operator if it has the two properties. And from these, we see, it follows that for all x and y and all constants a and b. The most common examples of linear operators made during school mathematics are differentiation and integration, where the above rule looks like this, and where u and v are functions of x, and b are constants, and r and c S are the limits of integration, and see also linear function for a subtly different use of the term linear. Thanks for your attention.